All right, it is Monday, June 1st. I'm so proud of you for sticking with us for June. We are at the last month, so our last day of this will be June 18th. I am so proud of you, and we are going to get through these 19 days together. So, while we get started, you are on lesson 9 today of curriculum, and today you're going to do a close read of chapter 6. Your big question today is going to be, how can changes in rocks over time be explained by the rock cycle? So last week we talked about what did we talk about? Metamorphic rock, igneous rock, and sedimentary. And then today we're going to talk about how those all fit together to, I'm sorry, my cat's behind the computer screen being goofy. How they fit together to create the rock cycle. On your exit ticket, the first half of it will be comprehension questions, and then the second half is going to look at vocabulary throughout the chapter. So it will be the bolded font, which is an informational text feature. And then you'll have to answer questions like fill in the blank questions with those vocabulary words. So you will have to infer. So I'm not going to go over those words with you and just read you the definition. I want you to use the context clues and your reading. So that's why I'm not going over those. And I said we're going to talk about the rock cycle. There is a question on your exit ticket about a metaphor. Remember, a metaphor is a comparison that does not use like or as. So the metaphor that they use is that minerals are the building blocks of rocks, I think is what they say. Let me double check that. Yeah, they're the building blocks of rocks. Your job is going to be to explain that metaphor. Now, if to make it a simile, it would be minerals are like the building blocks of rocks, but it does not use the word like or as, so it is therefore a metaphor. That kind of rhymed it. Didn't mean to. So when we're looking at this diagram, I was going to draw an anchor chart, but I think this is just a lot more helpful. And my art, if I tried to draw rocks, they would just all look the same. So let's just start here with igneous rock, okay? Remember, igneous rock is formed from magma that cools fast, okay? Or that cools, whether it cools fast or slow, changes the type of igneous rock. So we have igneous rock, okay? And then this paragraph right here I really liked, okay? So looking at the rock cycle, it has no starting or ending point. You can jump in anywhere to see how it works. So instead of starting at igneous, we're going to start with magma. Okay, so let's start with magma erupting from a towering volcano. The magma, which is now lava, cools and hardens, and it turns into igneous rock. Okay. Over the course of thousands of years, sun, wind, rain, and freezing temperatures cause the rock to weather. And weather means break down into smaller pieces. Okay, so now we have sediments. So this igneous rock has gone through some weathering and turned into sediments. The pieces continue to weather slowly. Howling winds, flowing water, and gravity gradually move the sediments down the sides of the volcano and beyond. Movement of sediments from place to place is called erosion. So let's imagine that the sediments end up down here in this lake, okay? They settle at the bottom. Over time, more layers of sediments are deposited on top. So then they're compacting and cementing together. So compacting and cementing processes eventually turn the deeply buried sediments into sedimentary rock. This is not like rock's been down there for 2 days and then turns into sedimentary rock. It's going to take years, like thousands of years. So imagine that the sedimentary rock is near the edge of a tectonic plate. So now we have sedimentary rock right here. Okay, but the plate collides with another plate very slowly, of course, and tremendous heat and pressure, which are generated by that collision, can turn the sedimentary rock into metamorphic rock. As the plates continue colliding, their rocky edges crumble. The metamorphic rock is slowly pushed up higher and higher onto Earth's surface. Think about mountains. Exposed to air, rain, and snow, the rock begins to weather and erode, right? So then it can turn back right here. So turned into metamorphic rock, and then it can turn back into sediments and turn back. Do you see what I'm saying? So it has no starting or ending point. That, I guess, is pretty much what I wanted you to know about the rock cycle. And then it's important to understand how rocks change because it helps geologists understand how Earth has changed over time. So looking at the patterns of the rocks changing helps us look at the patterns of the Earth changing. That was the big point I wanted you to get about the rock cycle. You will learn more about this as you read chapter 6 and answer those questions. That's all I have for you. I will be on Zoom 9 a.m. to 11 a.m. Have a wonderful day.